Good afternoon and welcome back to Dr. Logic awkwardly does logic in her kitchen. In this video, I thought we'd go through another example of how to calculate the truth of propositions in a quantified model. So I've already gone ahead and put up an example on the whiteboard. So we've got a domain that has some little colored shapes in it, a red box and a blue box and a red box with a slash through it and a green box with a slash and a green circle. And we have a language that consists of a unary predicate P, a binary relation R, and a unary function F. So the superscripts are just to indicate, is this binary, is it unary? Then our interpretation is such that we interpret the function so that if it's one of the slashed things, so slashed box, either red or green, goes to an unslashed box. The red one goes to red, the green one goes to blue. And then everything else just gets the green circle. The interpretation of the unary predicate P gives us both of the red squares, the blue square and the green square, so not the green circle. And then the interpretation of R, because this is a binary relation, we need to have pairs of things, and it's going to be the pair red square, blue square, blue square, green circle, red square with a slash, and red square with a slash and green square with a slash. Now, remember, order matters. So red square, blue square is not the same thing as blue square, red square. Then the next thing that we need in order to be able to start doing an interpretation is a variable assignment. So I'm starting with a variable assignment V that assigns the blue square to X and the green circle to both Y and Z. And then everything else, all of the other variables, we don't really care. So we're just going to say assign them to the red square. So this is everything that we need for our model. The sentences or formulas that we're going to look at to determine whether or not they are true are, let me get my notes. For every X, there is a Y such that Rxy. So everything is related to something. You can read it that way. Not for all X, Px. And for all X, if not Px, then there is something Rxy. So the way that we can read these are everything is related to something. Not all things are P. Anything that isn't P is related to something. So these are the sentences we want to know, are they true on this model and this variable assignment? So the way that we do that is we just work through the definitions of truth. Now, I'm going to actually start with number 2 because it's the easiest one of all. So we want to ask, is it the case that the model consisting of this domain and this interpretation, along with this variable assignment, does it make not for all X, Px true? Well, it makes it true if and only if this model and variable assignment doesn't make for all X, Px true. This is just the definition of negation. So now what we're going to do is we're going to kind of look at the things on the right-hand side of the if and only if, and just keep unwinding them. This is the case, if and only if. So when is it not the case that for all X, Px? So this is saying it is false that every X variant V prime is such that M V prime makes Px true. This is the case if and only if there is at least one X variant V prime where it's not the case that Px. So what this means is that we need to see, is there something in our domain that we can assign to x using this, keeping everything else the same, because that's the definition of an x variant, where that thing is not in the interpretation of P. So consider the variant that assigns to x the green circle. Then, let me just get my correct color back. Then what we have is that this thing, so i.e., let me write this up. Then this object, our little green circle, is not in the interpretation of P. Because you go over here and you look, and it has red square with a slash, blue square, green square with a slash. There is no green circle in there. So there is an X variant that makes PX false. Namely, this one that assigns X to this object. So so there is at least one X variant V prime such that PX is false. If and only if it is false that every variant V prime makes it true, if and only if it is not the case that for all X PX is true, if and only if not for all X PX is true. So the answer to number 2 is it is true on this model and this variable assignment. Let's clear out our space and consider number 1. You have to touch every single piece in order to erase it on the Zoom whiteboard. But there we are. Now let us consider number 1. So again, we can work through the definitions in this kind of chain of if and only ifs. So our question is it the case that for all x exists y, rxy is true on this variable assignment? It's true if and only if, and we can just unwind the definition of truth like we did in the other case. So this is true if and only if for every x variant v prime on the model with this new variable assignment exists y, rxy is true. Now, because this is talking about every x variant, we need to consider v itself, so where x is assigned to the blue square, but we also need to consider 4 other variants where it's assigned to the red square, the red slashed square, the green circle, or the green square. Now, I'm just going to have you consider one of these. So consider the x variant v prime, where v prime of x is I need to check something in my notes because my printed version did not maintain all of the colors. Okay. We want to consider the version where it is assigned the green slashed square. Then, so now we've shifted our attention to this new variant, and we can say, well, under what cases is it the case that exists y, rxy is true on this new variant v prime? This is the case if and only if there is a y variant, because this quantifier is quantifying over y, not over x. V double prime, such that on that variable assignment, rxy is true. So that is going to be the case if and only if whatever Let's write this again. Whatever this variable assignment assigns to x paired up with whatever this variable assignment assigns to y is in the interpretation of R. So R is this set of pairs. So this is going to be the case if and only if, well, we are considering this V double prime is a Y variant. So that means everything in V prime that isn't Y got fixed. And we said that V prime assigns the green square, the green slashed square to X. So we have that. We know that that's what V double prime assigns to X. Now the question is there something that we could assign to Y to fill in this second gap so that we have a pair that is in fact in the interpretation of R? If you look at our interpretation, at all of the pairs, the first element in them, none of them are the green slashed square. We have the red square, the blue square, the green circle, and the red slashed square. So there is nothing that we can put in here. So this means, in fact, we have an X variant, namely where we've put in our green square with the slash, where there's not going to be any Y variant that allows us to put something into the other bit, because there is nothing that the green square is related to in this first position. Don't be confused by the fact that it shows up in the second position in this pair that has the red slashed square and the green slashed square. What is important is that there is nothing in the interpretation of R that has the green slashed square first. So there's nothing that we can put second that will give us a pair that occurs in this interpretation. So if we work our way back, what we have done is we have found an X variant V prime where this is false. So it's not the case that exists Y RXY is true. So it's not the case for every X variant, because this one, it failed. So the result here is that this sentence that says everything is related to something is false. Now, I've got the feeling that I've been talking quite a bit here. So I think I'm not going to go through number 3 in great detail. I will leave this as an exercise for the viewer, but I will give you kind of the intuitive way to look at it, because sometimes it's helpful to have a sense of whether something is going to be true or false before you start going through the formal definitions. What this says is that everything that is not in the interpretation of P is related to something. Now, if you look, we've got 4 things in our interpretation of P, 5 things in our domain. The odd one out. Ooh, I didn't want to erase there. That was supposed to, let me try to put our domain back together. Sorry, domain. There we go. I wanted to be able to highlight this guy. That is the thing that's in our domain that is not in the interpretation of P. So it's the only thing that's going to make this antecedent true. And then we just need to say, can we find something to fill this second place that is in the interpretation of R? And yes, we can. So everything that is not in the interpretation of P, which is just the green circle, is something that is paired up with something in the interpretation of R, namely it's paired up with the slashed red box. So this one is going to turn out to be true, but I leave it as an exercise for you to actually unwind all of the definitions and show this formally for yourself. So if you do that and you've got any questions, feel free to leave them in the comments. I'm happy to check your work and explain any bits that maybe are not so clear. But it really is just a matter of going back to the definition of truth and falsity, and whatever type of formula you have, write down the relevant clause on the other side of the if. and only if. So I hope that was helpful. Hope it was interesting. Hope you'll join me again next time for more fun with predicate logic. Take care. See you then. Cheers.